Okay, so this is for a particular student, but it also applies to everyone else. This is the momentum conservation lab where gliders were collided into each other and then they pass through photo gates to get their speeds collected. So we're looking at a heating heavy, and we have these photo gates giving these numbers. So here's one number, one particular number. Gate 1 has 48.7 and then 0. And gate 2 has 48.3 and then 0. So how do you interpret this? Well, you should do this by thinking how this collision happened. So here's gate 1 and here's gate 2. Okay, so what happens here is there's this target that sits in between the gates with an initial speed equal to 0, right? So this is let's say M2. So V2's initial speed is always 0 because I kept it in between the gates with my finger, and I only let go of my fingertip right before the collision happened. So M2 was always held at rest before the collision. So here's an M1. It's a different story. M1 actually travels through this photo gate, right? So then collision happens right here. And the next picture is here. The gates don't move. But here M2 has been pushed out. And M1 here is coasting at very low speed. So M1's final is near 0, right? So you just take it as 0. All right, so let's take a look at the numbers now. This top line comes from the first gate. So the first gate recorded two numbers in sequence, 48.7 and 0. Actually, 0.0 means that there was no number. It was expecting two numbers, but only got one. So what does this number come from? Well, this M1 is actually passing through the gate, so its speed gets captured. So this number is M1's initial speed. And then the 0.0 means nothing. It's not M2's initial speed. It's just the gate only got one number. It was expecting two. Okay, so what about the second gate? Well, the second gate, this M2 was passing through the second gate, and only M2 passed through the second gate. M1 was so slow, I didn't allow it to drift through the second gate. So the second gate has a number 0 here, indicating it only got one readout. So 48.3 was actually here. The this one is M2's final. And 0.0. Let's do this. M1 initial 0.0. So 0.0s don't really mean anything. But the first number must be the first speed captured by a certain gate, right? So this gate here captures only one speed, the after collision M2 speed, right? So this is 2 final. That gets captured by this gate. And this is V1 initial that gets captured by this gate. That's it, right? So this is heavy heating heavy. And for the final speed of M1, for the initial speed of M2, you can assume them to be 0. They're not related to these two zeros that show up on the display. So that's one. And here's another example, heavy heating light elastic collision. So there are still zeros. That only means this is gate 1, right? Gate 1 only recorded one value because the heavy travels through gate 1 and it hits the light, and then both will travel through gate 2. The heavy does not go back and travel through gate 1. So gate 1 only gets traveled through one time by the heavy, right? So the first number is still V1 initial, and the second number 0.0 is nothing. Oh, 0.0, not 0, comma 0. Okay, it's not a big deal. Okay, what about this sequence of the second gate? Okay, so let's move to the right so we can draw a bigger diagram here. So here's gate 1, here's gate 2. So I'm just drawing after the collision. So here M1, it is still traveling, and it is traveling at M1's final speed. And M2 has traveled through at this point when I was drawing it. M2 has traveled through with M2's final speed. So this speed gets captured by gate 2. And immediately after that, this M1 will travel through the gate. So this gets captured also by gate 2 after that. So this is actually the first value captured by gate 2. This is the second value captured by gate 2. In the sequence, the objects, the gliders went through gate 2. And what about gate 1? Gate 1 only got M1's initial speed. That's why it has a 0, right? So here, this should be the M2's final speed because that's what went through gate 2 first. And then M1 follows through, oops, there, M1, right? 1 is final speed. It's actually, it's backwards to 1, right? So think about this. Most collisions can be explained in these two cases, except for the light hitting heavy, where the light object, light glider, actually bounces back. So what happens when that is your case? Okay, so let's draw this instance where after the gliders have collided in between, this M1, which is lighter, will actually travel back through gate 1. M2, which is heavy, will travel through gate 2. So the first number here that gate 1 captured was still the M1's initial speed because M1 needs to go from left to right through this gate. And then the second number is this. One's final speed gets captured after, and as a negative, it should be a negative, but the gate does not record a negative value, right? So the first speed captured by gate 1 is the initial speed of M1. The second speed is the final speed of M1, and you must put a negative to get the velocity because momentum requires sign. And here, gate 2, on the other hand, only gets traveled through once by this M2 at V2 final, so that the next number will actually be 0.0 again because gate 2 only gets traveled one time. So this is the light heating heavy elastic. Oops, just trying to squeeze in while holding a pen. Okay, so the first gate should show M2's initial velocity, and then the negative of M1's initial velocity, and then the negative of M1's final velocity. So it is going to show a positive quantity as a second number, but you want to put a negative in front of it when you enter it into the M1's final velocity. And then gate 2 should just show M2's final velocity and the 0.0, which is irrelevant, right? So hopefully this video helps you understand how to get the numbers into their proper locations. I think what this student did was excellent. The student went through and wrote down everything that I said. Please read and write down the gate values. As the student did, the gate values were written down. So at any point you can think back how you were doing that, how the gate, how the gliders were doing the collisions, to think about which number from which gate belongs to which gliders, initial or final. Just kind of draw these diagrams. If you don't want to draw diagrams, put two cups on your table and have I don't know, two coasters move along the cups pretending the cups were gates. This should help. This is the especially difficult one, the light heating heavy elastic collision, because there's a bounce back. You have to attach a negative.